Hi, welcome back.
Hello.
Hello. So how's it going?
Good.
Great. Well, let's continue on our exploration of geometry stuff. We're working now on line segments and distance. I'm updating my title over here for my recording because it didn't update and I don't know why. There, okay, I know you guys didn't see anything on the projector, but it changed. All right, so let's get some terms taken care of. So a part of a line that consists of 2 points, which are called endpoints, and then all the points in between them is a line segment. So it's just a piece of a line, has 2 endpoints, and we're going to name it by its endpoints. So this line segment's name is line segment AB. Draw the line segment, no arrows this time, and then AB underneath it. But just like the line, this isn't the only way you have to name a line segment. You could also name it BA, line segment BA. Again, make sure you put the symbol above the letters, because if you don't, you're calling it something else. And if I've asked you to write the name of a line segment and you forget the line, I'm not going to be able to give you credit because you didn't name the line segment. You named something else. Points between some other points. So this is betweenness, is this term. And here's what it means. So I have this line segment P to Q. It's like I've got this row of gentlemen, right? And we've got P on one end, and we've got Q on the other, okay? And between them, we have some other point M, okay? So M is sitting somewhere between P and Q. That happens only if they're all sitting in the same row. They're all collinear. I couldn't say that between P and Q, I have point C for Christina. That makes no sense because she's not on the line with them. She's sitting over here. Okay? And if that happens, we can take, okay, notice how there's no symbol above these letters now? That means the distance between those letters. So the distance between M and P, we add it to the distance between M and Q, and it's going to give me the distance of the entire thing. Okay? I'm going to put some colors to get it to make more sense. So the distance between this portion plus the distance between this portion is going to give you the entire length all together. All right? That's what we're going to be playing with down toward the bottom. So I'm going to pause with the definitions for a second, and I'm going to scoot all the way down so that we can use this betweenness sort of thing. Okay? All right, we're going to look at example number 1. If you feel that you may need a calculator, you can bust out your phone's calculator app, or you can grab a superhero. All right, we want to find the measure of JL. JL is the entire segment. We were told that with betweenness, I can take this piece and I can add it to this piece, and it'll give me the entire segment. Okay? So I'm going to write that. This piece plus this piece equals the entire segment. Notice how, even though I'm talking about the segment, I'm not putting that symbol up in front of it. All right, the measurement of this piece is 8.4. The measurement of this piece is 3.9. I'm looking for the measure of the whole thing, JL. And now I can do my addition. 4 plus 9 is 13. Carry the 1, that's 12. And I had 1 decimal place. And this is centimeters. Is that easy enough? We took like a piece, I had this segment, and I had this other segment, I added them together, and it gave me the length of the entire thing. Okay? So let me color for you. Here's this piece, here's this piece, and all together it gives me the whole thing. All right, let's look at it in terms of number 2. All right, I want to find the measurement of QR, so I'm going to find Q and I'm going to go to R. I'm interested in the length of that piece. Remember that my betweenness says that I can take part of the line segment, add it to the other part, and it'll give me the whole. So I have this part from P to Q. I'm going to add to it this part Q to R, and it'll give me the entire segment P to R. Okay. So this piece plus this piece gives me the entire thing. But I don't know what this one is. So I'm going to leave it listed as QR. QR altogether will become my variable. Okay? So I'm going to fill in the length that I know for PQ. So my length for PQ is going to be 6 5/8 foot. I don't know what QR is. And I know the length for PR listed right here, 13 3/4 foot. To solve for QR, to get it by itself, I need to get rid of this piece. Huh? Yeah, I'm going to subtract it. So I'm going to subtract both sides by 6 5/8 foot. So QR is whatever I get when I complete this subtraction. And I don't know about you, but that subtraction looks a little scary. All right, when you're subtracting fractions, and I'm going to look at just the fraction portion, I'm not going to worry about the whole numbers yet. When we're subtracting fractions, we want the denominators, the numbers on the bottom, to be the same. Right now they're different. If I multiply 4 by 2, I get 8. So what I'm going to do is I'm going to trade out the denominators for 8. Now in this bottom fraction, there's nothing to do because it's already 8. But in this top one, I need to multiply 4 by 2 to get 8. So I'm going to multiply the top by 2 also. 3 times 2 is 6. And now I can subtract 6 minus 5.
1.
Okay, so far so good? Okay, so 6 minus 1, as you said, was 5. So, or 6 minus 5 is 1.
Yep.
And I didn't need to borrow any because my top numerator had enough in it. And so I'm going to do 13 minus 7 now. 13 minus 6 now, which is 7. I have a hard time with my numbers.
Why did you multiply it by 2?
Why did I multiply it by 2? Because I wanted these denominators here to be the same. And right now they're not. And the only way to get them to be the same is to multiply 4 by 2. All right, and so this gives me the length of QR. So far, so good? Okay. Let's do one more. We're going to look at number 3. Number 3's got some algebra involved, so we're going to solve an equation to make this happen. All right, I'm told that the whole thing from x to y is that amount. And then this little piece here from x to y is that much, and from y to z is this much. Our setup is that one piece plus the other piece equals the entire segment. Okay? So far, so good? Now I'm going to substitute in what I know. What is the measure of xy? 3a, whatever that is. I don't know what a is, but I can write 3a. What is the measure of yz? 14. What is the measure of xz? 5a minus 4. And now I can ignore my figure and I can pretend I'm way back in Algebra 1 and I can solve this equation for a. Problem, I've got a's on both sides of the equal sign. I'm going to collect them all to one side. It doesn't matter which side you put them on, the left side or the right side. You'll get to the same answer. I'm going to put it on the right side because this number in front of the a, the coefficient, it's the bigger one. Okay, and that helps keep it positive. It gives me less work in the end.
Then you gotta subtract it.
Yep, I gotta subtract 3a from both sides.
I thought you subtract, what is it?
The 5?
Yeah.
You could. You totally could. I just, because this 5 is bigger than the 3, if I subtract 5, I'm gonna end up with a negative. I ain't got time for that. I don't wanna deal with negatives. So I'm gonna subtract the smaller one because it leaves my variable positive.
I mean, does it matter if you get if you did the other way?
No, it doesn't. You're gonna get to the same place. I don't wanna deal with the extra work of dealing with a negative there. So that's why I make this choice. Okay. But the choice is yours. All right, I need to get rid of that subtraction by 4. 14 plus 4 is 18. I was about to write 28, so thank you guys for fixing that for me.
9.
Yeah, and then I'm going to come over here. I just rewrote it because I was out of space. Divide both sides by 2 because this means multiply by 2, and I want to undo multiplication. So I'm going to divide. And A is 9. So what it wanted, what the directions were asking for, was to find the value of A and the value of xy. So I found the value of A, and now I'm going to find the value of xy. So this is 3 times whatever A was. 3 times 9 is? 27. And so the distance of xy is 27. And so this question has 2 answers. Fair enough?
What about x to z?
Didn't ask me for x to z.
Oh, yeah.
Yeah, my directions just wanted to know what A was and what the distance between x and y was. Cool. But now that you know what the distance between x and y is, and you know what A is, you could find the distance between x and z if you wanted, but it doesn't ask me, so I'm not going to do it. All right. Come back up to the definitions. If things have the same measure, we're now going to have a very special word for it. Here is 2 segments. They both measure 1.7 centimeters, and we're going to put this mark, a little line, through the line segments. And that little mark, anytime we have it on a drawing, is going to say that those things that have the same number of little marks, they're all the same distance. Okay? And the word for they have the same measure is congruent. So if we're the same height, we're congruent. If we weigh the same,
Or
we're
congruent.
congruent. If we're the same age,
Congruent.
because those measures are all equal. Yeah? Okay. So we've got a method of creating geometric figures without using measuring tools. Okay, so we're not using protractors. We're not using a ruler. Okay, so we can't measure the angle and we can't measure how long the thing is. When we do that, we use only some sort of writing utensil, a straight edge, which literally is like the straight edge on a piece of paper without any marks. You could use a ruler, you just have to ignore the marks. And then a compass, and there's a picture of the compass. A lot of you had those out yesterday. We'll play with those in another day or so, so if you haven't gotten your compass and protractor set yet, go do so like tonight, okay? Okay. This method of creating figures is called a construction. You will all now be Bob the Builder.
All into that thing.
Yeah, and you will be doing some construction in this class. Okay? Let's see here. All right. Turn the page. And fill in this word here with the word distance. Because the distance between 2 points is the length of that segment with those points as its endpoints. The coordinates of those points are used to help us find the distance. Because we don't have a way to measure yet, okay? We don't have a ruler. But we can use distance formula. We can assign numbers to every point, and then we can count how many numbers are between those points. And that becomes our distance. So on a number line, our distance formula looks like this. Do you remember what those upright bars meant?
It's,
Absolute value.
Very good, it's absolute value. Do you remember what absolute value did? Absolute value tells us the,
I'm sorry, wrong number.
thank you. Absolute value tells us the distance we are from 0. And so it's going to make every number in there positive. Like, once you get it down to a single number, it's going to turn it into a positive. Okay, because distances can't be negative. Okay?
true.
Distance from 0. Okay, let's practice a little bit. Okay, we're going to use the number line and we're going to find AD. We're going to calculate it first and then we're going to sit there and actually count. Okay, just to confirm. All right, my formula says we're going to take the absolute value of whatever the coordinate is at one point minus whatever the coordinate is at the other point. All right, what's the coordinate at A? -7. What's the coordinate at D? -2. I've got a double negative sitting there. What happens when I have a double negative?
Positive.
It turns into a positive, so I can immediately exchange these for positives. And now I have -7 plus 2. We're adding or subtracting, the signs are different. So you're gonna, yeah, we're adding them and the signs are different, so it feels like a subtraction. And so from -7, you count forward 2 times and you get to 5. Okay, -5. What's the absolute value of -5?
5.
5, because you have to take 5 steps to get to it from 0. And so the distance between A and D is 5. Let's count it. Start at A, and we're going to count toward the positive direction. We're going to count this direction. 1, 2, I've added 2, look, I'm at -5. Okay, 2, 3, 4, 5. I had to take 5 steps to go from A toward D.
So wait, can we just do that instead of doing that?
You can, but if I go show the work, I need to see this.
Can't you just not take 5 steps?
If I give you the number line and I see the little bouncy thing, I won't be upset. I'll know that you counted the steps.
Okay.
But if I don't give you the number line, I just hand you a bunch of coordinates, you might not be able to because I'll make the numbers really big and you'll be there counting for forever. Right? And you've got other things to do with your time than sit there and count little hops. Okay? So you just drop them in this formula. All right? All right. All right. Determine if CF and AE are congruent. What did congruent mean again? Equal measure. So we want their measures to be the same. Okay, so let's count CF from C to F. So C, we're going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9. So CF is 9. AE. Start at A and I'm going to count to E. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yes.
Yes, because we have the same measure. They are congruent. Cool? We did this in one dimension. We did this on a line. We only had one direction we could move, which was along the line, one dimension. Now let's talk about it on a coordinate plane. Piece of graph paper, 2 dimensions. We could move left or right or up and down. Our coordinates, our points now have 2 coordinates. We have an x coordinate and a y coordinate. Feel familiar?
Oh, yeah.
So we have x1, y1, x2, y2.
Isn't it like x2 minus, or y2 minus y1 over x2?
Yeah, okay, it's related to slope in a way, but we're talking distance, and you had said something like y2 minus something, and then we did something else, and then there was a thing. Okay,
Yeah.
perfect. Okay, I'm gonna write it. Wait until I'm all done, because I'm gonna color code as I go, and so I'm gonna leave spaces, and it's gonna look really weird, okay? So, okay, wait. Don't write it yet.
Oh, shoot.
Right? It looks really crazy. Okay.
Say greater.
Yes, you would have seen distance formula a little bit last year. And you likely would have stuck it in your calculator and gotten a decimal and found the multiple choice answer and colored in the bubble. And everyone would be happy. And this year, I'm going to be asking for the exact distance, which means you have to give it to me with the square root still involved. So you remember the simplifying radical thingy that we did with the little puzzle and the stuff? Yeah, you got to do that. All right. Let's practice. Here we go. We're going to find the distance between each pair of points. And I'm going to label them. One of these points is x1, y1. The other one is x2, y2. No one cares which one is which. Just pick one and go with your choice. Which point, C or D, do you want to be x1, y1? You want D to be x1, y1? Okay. So he has selected that D be x1, y1, and that forces C to be x2, y2, and so I've labeled it this way. I'm now going to substitute into here. Okay, my distance between CD is equal to the square root of y2 minus y1, that thing squared, plus x2 minus x1, that thing squared, all of that under a square root. I'm going to take a breath because that was a lot of work. Okay, I'm going to start to simplify now. Okay, I'm going to show you how to do it by hand. You can use the calculator to help you with some of the numbers, but I want to show you how to crank through it by hand, manually, okay? I have a double negative, so I'm going to turn it positive. And so in here, in the y's, I have negative 6 plus 1, which is negative 5. That's squared plus. Here I have negative 4 minus 5. That's a negative 9. That's squared. And then I'm going to take the square root of all of that. The next line. All right. Negative 5 squared is the same thing as negative 5 times negative 5. 25. A positive 25.
81.
And that's 81. A positive 81, because negative 9 times negative 9 is positive 81.
106.
You are so good at this mental addition thing, dude.
Maybe.
You said 106?
Yeah.
All right. And now I've got to simplify that. So I'm going to list out some factor pairs to try to find one that's got a perfect square in it. 106 can be divided by 2, so that's 2 times 53. I'm looking at 53 and I'm trying to find numbers that divide into it evenly. It's not even, so that rules out 2, 4, 6, 8, and 10. If I add 5 and 3 together, I get 8, which isn't divisible by 3. So that's not divisible by 3. It doesn't end in a 5 or a 0, so it's not divisible by 5. 7 times 7 is 49. 7 times 8 is 56. It skipped 53, so it's not divisible by 7. And that's it. I don't need to check any others. Yeah, it's prime.
You're good.
I'm good. I checked all the possibilities. I did my, you can use the calculator juice. You go 53 divided by 3. If you get a whole number, it works. If you get a decimal, you clear it and say that one doesn't work and you throw out 3 and you try the next one. Okay? And you keep going until you can't find any more. I've done a pretty exhaustive list. I think any others, I covered them all. So, yeah, this is prime, which means this is about as exact as I'm going to be able to get it. Because I can't simplify. But I went through the process to check to see if I could. All right. Do you want to practice it one more time? Yes? All right. So I need someone else who hasn't had a chance yet to pick a point to decide which point, M or N, is x1, y1. Whichever point you pick is the correct point. Which point do you want to be x1, y1? Which one? 2, 4, so point M? So point M will be x1, y1 today. Okay. So she's made a choice. We're all going to stick by her choice. And now the distance between M and N is, and I'm going to substitute using my formula from up above. So I'm going to do y2 minus y1. That stuff is squared. x2 minus x1. That stuff is squared. And all of that's under square roots. Okay. I'm going to simplify. I'm going to start with the very insides. -2 minus 4, -6. -3 minus 2, -5. Okay. -6 squared is -6 times -6. 36, and it's a positive. -5 times -5 is 25. All right, 36 plus 25 is 61, okay. All right, now I need to check to see if I can simplify square root of 61. It's not even, so I'm going to throw out 2 and 4 and 6 and 8 and 10. Can't divide by any of those. If I add 6 and 1, I get 7. 7 isn't divisible by 3, so I can't divide 61 by 3. Can't divide it by 4, because I couldn't divide it by 2. It doesn't end in 5 or a 0, so I can't divide it by 5. I can throw out 6 because it's not divisible by 2 or by 3. 7? No, because 7 times 9 is 63. And that's just a little too big. It's not divisible by 8. We just did 7 times 9, so it's not divisible by 9. Okay, so this thing's not divisible by anything. That's as close as I can get it. But notice how we took a moment to verify and to check.
Can you even multiply anything to get 61 besides 1 and 61?
That's what we were checking for.
No, like
You can
even if
use a
it's not
decimal.
like a perfect root, like I don't think
When we're dealing with the square root things, we're looking for those whole number integer looking factors. So we're not going to allow any fractions or any decimals. Yeah, right? Yeah, good, because that just hurts my head. All right, so we got another formula for you. Take a deep breath.
lot of notes today.
There's a lot of notes today.
I like it.
You like this? Good. This is the midpoint formula. It just takes some time, little boy. You're in the middle of the line. You're halfway between your two endpoints. Here's your formula.
That's all you need.
All right? Jimmy World.
I like
It's
that.
in the middle. You just take the 2 point, the coordinates, you add them together, you divide by 2, you're done.
Sing it again.
That sounded way too
Sing it again. Oh.
Here's your formula. Here's your formula. Here's your formula. The midpoints. Now this is on a number line, so one dimension only. Your midpoint on one dimension, I'm going to put x, is going to be x1 plus x2 divided by 2. The coordinate of one point plus the coordinates of the other points divided by 2.
Oh,
That's so easy.
That's it.
So wait. So, yeah.
Yeah. All right, let's practice number 9.
and B.
All right, what is the coordinate for A?
Negative 12.
-12. What's the coordinate for C? 6. All right, my midpoint formula says I'm going to take the first coordinate. I'm going to add to it the second coordinate. I'm going to divide the answer by 2. -12 plus 6 is -6. -6 divided by 2 is -3. And so the midpoint, the point halfway between A and C, is 3. -3. And that's it. That's your midpoint. You're done. Easy peasy? Do you want to see the other example or nah, let's move on. Move on? Move on? Move on? Move on? Move on? Move on? All right. So you know how we did distance formula? We did it on a number line. And then we did it on the coordinate plane. We just did midpoint on a number line. So guess what's next? Midpoint on a coordinate plane. Same idea, except this time each of our points has 2 coordinates. So we have to do this thing twice, once for each coordinate. And so your midpoint now has 2 coordinates. The formula looks like this. Okay, calm down.
Why are there two commas with the?
Because I've got 2 coordinates. I'm going to calculate it for the x, and I'm going to do for, it becomes like an ordered pair. Would it look better if I do that to it?
Yeah.
Okay, I'll do that. Remind me that I have to do that, because I forget.
Oh, there's a comma right now too.
Because it's an ordered pair.
Yeah.
It's an ordered pair.
Because we're doing Y and X.
We're doing a y version, and we're doing an x version.
Oh.
All right? All right, let's practice it. We're going to practice it on number 11. That way I can keep my formula going. Okay, we get to pick, just like we did with distance formula. One point is x1, y1. One point is x2, y2. Someone who hasn't yet had a chance to share, tell me which point do you want to be x1, y1? Go ahead, pick a point between C and D. Which one do you want to be x1 and y1? You can't be wrong. D. Okay. All right. So D she selected for us is x1, y1. That makes C x2, y2. And now we can do our formula. Nice choice. Thank you, ma'am. All right. So our midpoint.
Oh wow. You really have to.
All right. Our midpoint is going to be x1 plus x2 divided by 2. And then the y coordinate is going to be y1 plus y2. All right.
And that's it.
And now we're just going to calculate this out. So the midpoint's coordinates in xy is 5 plus -8 is -3, okay? -3 over 2. And then 1 plus -2 is,
Is that a -8? It's
No, it's
-1
3.
No, right up there.
right here?
Yeah.
Yeah, it's a -8. And this one was -1. over 2. And we're going to leave it like that. You don't have to convert fractions into decimals. The fractions have to be in lowest terms, but you don't have to give them to me in decimals. Bless you. Did you want to see another one like this? Okay, yeah, because we're getting close to bell. So we found the distance from one point to another. We found the halfway point. Hi. We can also find it some fractional distance. But let's say I don't want to go all the way for myself to Yazzie. I only want to go halfway. I did that. But what if I only want to go a third of the way to Yazzie?
Then you divide by.
Okay. Then I've got to figure out the fractional distance. So you're going to find other fractional distance from an endpoint by multiplying by the fraction of the distance you're trying to find with the total distance. Okay? So we're going to take our total distance and you're going to multiply it by that part of the distance that you really want to travel. Okay? So part times whole will give us the coordinate of where we should stop. Okay? We're going to look at number 13. Use the number line above to find the point on C to E. That's 1/8 of a distance. Okay, so we need the coordinate for C and the coordinate for E. What is the coordinate for C? -4, and the coordinate for E? 2. I need the distance between these 2 points. We have a number line, so we could totally just count it. Okay. So 1, 2, 3, 4, 5, 6. So my distance, my total distance is 6. I only want to go 1/8 of the way. So I'm going to take this distance and I'm going to multiply it by 1/8. Whenever I'm multiplying fractions, I can think of the 6 as over 1, exactly what you just said. And now, all I have to do, whoops.
Liz, can I ask a question?
Yes?
You have to take a star test, please.
No.
Oh,
Okay,
thank
well, what
goodness.
about an EOC?
Nope.
Okay.
What about, like,
what about
a-
chemistry?
I don't think so.
Oh,
Yes. All right, we're almost done. Like 3 seconds on this and we're done. Refocus, 3 seconds. Ready? 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 Okay, so multiply fractions, go straight across. 6 times 1 is?
6.
And then straight across, 1 times 8 is? 8. Let's put this in simplest terms. 3/4. And so the coordinate that is 1/8 of the way from C to E is 3/4. That's all I had for you today. Thanks.